morning. Today we'll discuss about the supervisory relay. We have seen that to avoid false alarms due to CT saturation, we will be using high impedance differential scheme of bus bar protection. In addition to that, we will be employing supervisory relays also. In today's class, we will see why we do employ supervisory relay and how do they operate. In the last lecture, we have discussed about representation of internal fault, and we have also determined the minimum fault current which your relay high impedance bus bar protection can detect. And this has been right. This was the expression which we derived in the last lecture. So in today's lecture, we will determine the stability ratio of high impedance bus bar differential scheme, and also we will see the operation of the supervisory relay and what faults it can detect. So I will start with stability ratio of high impedance bus bar scheme. It is very simple ratio which it states that, see here, the stability ratio of high impedance bus bar differential scheme, it is defined as the ratio of maximum external fault current for which the system remains in stable state to the ratio to the minimum internal fault current which can be detected by the scheme. As already we stated, maximum external fault current, your system must be in stable state and it must be also able to detect minimum internal faults. So the ratio of these two is defined as a stability ratio of high impedance bus bar scheme. This is a dimensionless quantity, and the higher the value is, it says that the better is the quality of differential protection, which means that it is capable of detecting very minute magnitude of internal faults, and it is capable of withstanding large amounts of external faults also. So normally the stability ratio will be of the order of 10 to 100. So the higher it is, the better is the protection. It's an indication of improved protection schemes. Okay. Now we will see an improvement or an addition to the high impedance bus bar scheme. We call it as supervisory relay. Why this is being employed is, in a bus bar scheme, what happens is we do have a number of feeders, and each of these feeders will be having a separate CT. And the high impedance bus bar scheme is employed if any CTs get saturated. It's not only the problem of saturation, but it's a problem of their open circuit also, which happens in the power system. So sometimes your particular series circuit may get open circuited. Why it becomes open circuited? Maybe because of the pilot wire which is connected to that one, it may have broken. So because of that, your CT might have got open. So if your CT gets open, there will be a spill current flowing into your circuit. I'll show you. Now let us suppose there is an 2 incoming, 2 outgoing system is there. 2 incoming feeders, 2 outgoing feeders. Now let us suppose now see here, this is giving 5 amperes, this is giving 5 amperes, this is giving 4 amperes, this is giving 6 amperes. Let us suppose like this, okay. So what is the summation of current which is flowing here in this direction? It is 10 amperes, right? And here also it is 10 amperes. So normally, ideal case, a relay will not operate. But in case if any of this pilot wire has been broken, and here there is an open circuit. Now what is the current which is flowing here now? It is only 6 amperes of current is flowing. Here there is no saturation just because of your breaking of your pilot wire. One of the CT is getting open circuited, and say only 6 amperes is flowing. So automatically what happens? There is a spill current of 4 amperes flowing in the circuit, which will give an alarm for you. It is not an internal fault, it is not an external fault, there is no saturation of CT, but since the pilot wire has broken, since your CT has open circuited, now you are getting an alarm. Why? Because there is a spill current flowing in the circuit. So this is to be avoided. So normally what happens is the current contribution of an individual CT. Generally, it will be very much less than the pickup value of the OC relay, and the scheme will remain insensitive to such CT open circuit faults. But we need to develop some mechanism, particularly when one of the CTs gets open circuited. So most of the times what happens is there will be too many number of CTs in a feeder circuit, and the pickup value will be very high. But what happens is, if there is a one CT which is having very high amount of current carrying flowing through it, then it may result in the highest spill current also. And if there is a high spill current, if it is greater than your pickup value, then it blows up the alarm. So the highest spill current in case of loss of one CT secondary circuit will be caused in case of CT which carries the maximum load currents, which is your I load max. If this goes on, then there will be the highest spill current, and there is your highest probability of tripping of your circuit. So we need to protect our system, and at the same time we should avoid false alarms. So now let's see a figure now where a normal load is being supplied by the feeders, and there is a 2 incoming, 1 outgoing feeder circuits. The common one which we have been seeing right from the start of this unit, ABC. So assuming that this has been tripped and there is a spill current which is flowing in the circuit. So if this is being tripped, only one side current will be flowing. IA by N will be flowing and IB by N will be flowing. Actually, this is to be countered by IC by N. Now it is open circuited. So this entire current will be flowing in my circuit, right? So this is what I will show you. See, this is IA by N, right? And this is IB by N. Both currents will be flowing in this way. And from here, IC by N must come. But since there is an open break here, see, ideal case, IA by N plus IB by N, you ignore the magnetizing currents, okay? This is the case. So literally, what is the difference between them? It is 0, or it will be less than your pickup value, so no relay will operate. But if it becomes 0, this value is not going to be less than IPU, your relay will give an alarm, isn't it? And because of the loss of this current, see, there is a voltage drop which is being developed across this circuit, because there is a current flowing, right? So there is a voltage which is being developed across stabilizing resistance and relay resistance. Why it is being developed? Because there is a current flowing in the circuit, isn't it? Now if you are able to identify if there is a voltage being developed across this point, across these two, if it is greater than your small value, then automatically it means that some of the currents are not flowing in the circuits, isn't it? Which means that it's an indication that there is an open circuit, isn't it? So what you should do, you must choose an voltage relay which operates such that if there is a voltage being developed across this one, if it is greater than your pickup value, then automatically it must give a signal that one of the CTs is open circuit, isn't it? So that's fine. Here comes the concept of supervisory relay. Now, if you carefully see, this is a supervisory relay. Normally, it will be open circuits. So the supervisory relay is set to pick up at a voltage which is equal to the maximum current. This is your maximum current into the resistance which is flowing in the circuit. This is what I have shown here, isn't it? I am neglecting magnetic circuits. So the setting of supervisor relay, it will be very much less than your V set actually. So your supervisor relay, as I already shown you, see, this is my, okay. So my supervisor relay will act whenever there is a voltage drop which is being appearing across my stabilizing resistance. Under normal conditions, there must not be any voltage drop. If it is of a good value, then automatically your supervisor relay gives an alarm and indicates that one of the CTs is open circuit. Understood? So I hope that now you have understood what actually supervisory relay is and how does it work. Okay. So I hope that now you are able to describe the operation of supervisor relay. And in the next class, in the regular class, we will determine what actually this what voltage setting of supervisor relay is. Now you go through this theory question and come back to the class with full preparation of what actually supervisor relay is, and we'll try to determine the setting of your supervisor relay in the class. Thank you.